So hi everyone, so I'm Justine and today with Thérèse we're happy to talk about how we leverage LLMs to actually build data sets and then train smaller models. We are data scientists at HelloWork, which is the French leader in the talent acquisition tech, so job search website, code search websites, and basically we offer a wide range of services to connect either candidates and recruiters or students and training centers. And first, we wanted to talk about why we decided to give this presentation. So in the data science team, we work on all sorts of machine learning problems, and today we'll be talking mostly about named entity recognition. And up until 2020, the traditional approach was to design some manual features, maybe use a word2vec or BERT embedding, and then apply a classifier on top. And these are now considered small models, and they all require datasets for training and evaluation. And these datasets, you want them big and of quality, which means that usually you have to manually annotate them. And this phase is time-consuming and also, let's be honest, kind of a pain to do. But now the year is 2024, and everyone knows that LLMs make wonders at most NLP problems. Of course, you need to work on your prompt a bit, but there's a plethora of pre-trained models, and they are easy to use. They usually give pretty good results. And what's interesting is that they usually do so in a zero-shot or few-shot manner, meaning that you don't need the big annotated training dataset. And even if you decide to fine-tune your own LLM, usually you do that unsupervised, so it's a whole different kind of effort. But for many reasons, in reality, you may not be able or willing to use an LLM in production. Maybe it's because of the cost, because either you have to pay for an API or afford the infra to run the model yourself. Sometimes latency is the issue. You need a result in milliseconds, and generating text can take seconds, more likely. Or maybe your company is mindful on the cost on the environment, because all these large models, they require more computing power, water, etc. You may be concerned by privacy issues. I mean, working on resumes, we certainly are, and we just can't send our data to any API just like that. Or maybe if you can use an API, then the problem of vendor locking is just around the corner because you are potentially tied to that API, and your company strategy might be to avoid that. Or sometimes, based on the problem you need to solve, a custom solution might be better. But building a custom LLM from scratch, or even fine-tuning one, is just not feasible for every company. And that's okay. Not using an LLM in production is often not a problem, as we can achieve perfectly acceptable performance on specific tasks with a simpler model, as long as we have a good data set to build the model. So we need a good amount of data points. We usually want them balanced, and also representative of all the different cases that we'll encounter in real life. And for most problems, at least classification and ER, we need this dataset to have a ground truth. And now the question is, how can we obtain such data? And this is what this talk will be about. Instead of focusing on using an LLM in production, we will see how we can leverage them in to accelerate the R&D phase. To build a good but small model that will be a great contender for a production setup. So this approach is actually discussed in many research papers, and we were looking for answers to questions such as, can we replace manual annotation with auto or at least semi-auto data annotation? If we do that, how much time and effort we will actually save? And what are common pitfalls to avoid or good tips and tricks to know? And we have sought to apply it to a real business context, and that's what we will present now.
So the two use cases we'll discuss are name entity recognition task. The first one is about improving salary extraction from job offers. Salary is a key information in the application process for candidates, and here we deal with only a part of the job offer, the additional information part, which can contain type of contract, dates, advantages, remote work information, etc. It may or may not contain the salary. The extracted salary is then displayed in several parts of the HelloWork website. For example, here on the search result page. It is why our model must achieve really high performances. Here we try to improve an existing model which is used in production without new manual annotation. It's the third version in production, and the F-score is already great, but we have some false positives, and it's the type of error we really don't want because we cannot display an error for salary on the job ad. It's a logistic regression, so it's a light model, it's fast, and it runs on CPU. It was fitted on 20,000 manually annotated data and synthetic data generated using regular expression and rules. So we try to improve this model, and we try to find if we can match the performance we already have with a fully automatic data set. To be able to answer these questions, we need a test data set. We think that manually annotated test data set is a must-have. On trained data set, some errors of annotation can exist, as we can hope that they will be masked by the large amount of data. But evaluation must be reliable, and 100% annotation accuracy cannot be obtained with LLM or any other automatic approach. We must ensure that we don't introduce bias, and we must ensure for fairness, especially in the context of the AI Act, which has been voted in the European Union. We used 3,000 existing annotated texts and 6,000 additional new texts. The performances of the models are so good that it was difficult to find any differences, so we selected rare text. So what can we do to generate this trained data set? We used question answering model for this task. So you have the text, the original text, your question, here, what is the salary? And you obtain a span of text, the beginning position, the end position, and a probability. So you have a formatted output, and it's easier to treat after that. The selected model is QM-Mbert large. It's a model designed by a French laboratory near Bordeaux, the Catier. And the evaluation on our manually annotated test data set showed us that bigger model is necessary. We tried QM-Mbert based, but it was not sufficient. We had few false negatives, but quite a number of false positives with high probability. For example, 13e mois. It's an understandable mistake because it's about salary, but it's not what we are looking for. At this step, we thought that it may be hard to have a fully automatic data set generated with only one model if it's not designed specifically for our task. So what can we do to improve this first data set to make it fit with our specific task? It's really a balance between quality and time spent. First, we identified two approaches. The first one is about filtering data. For example, you can keep only results with very high or very low probabilities, but you may omit interesting examples. You can clean data with regular expression. We did that, and it was quite good, but it does not scale up well, and it's quite time-consuming. And you can also validate the presence of salary in the text with a zero-shot classification. With the filtering approach, you can miss interesting example, but it remains fully automatic. You can also manually annotate carefully selected data. For example, the QA result with intermediate probabilities, or data with a disagreement between the QA model and a baseline, if you have one, or zero-shot classification, for example. We tried all these approaches, but we'll only present the best results obtained. The best performances were achieved with fully annotated, automatically annotated dataset filtered with a zero-shot model. And we were able to slightly improve our results, and in particular, we have decreased the number of false positives, which was our main goal. Can we replace manual annotation with auto dataset creation? Yes, on this task. How much time and effort do we actually save? We had effort to do to design the pipeline, but after that, it was free to add new data. And what are common pitfalls, tips, and tricks? We think that we do not trust one single model, especially if it is not designed for a task, but build an ensemble approach and combine with human information or other model information to improve the dataset quality. Let's see what happens on the second use case.
Okay, so now the second use case is about a named entity recognition model for skills in resumes. So this time we start from scratch and we want to train a model to find the skills in a resume, and for that we need a dataset annotated with the correct entities in the text. And we thought, well, we could ask an LLM to help us find the appropriate spans. And the first step is to think thoroughly about what we want. Because unlike an NER task for names or for numbers, what a skill is in a resume is very subjective. We had many discussions about, do we include soft skills? Is it only tools? Do we look beyond the identified skills and languages section of the resume, etc. And it needs to be very clear in your head what you want to be able to find the words, to write a good prompt and get an LLM to output what you expect. So in the end, we decided on 4 types of skills. Skill, which could be a hard skill, soft skill, tools, software, etc. Certifications for stuff like special vehicle permits, spoken languages with their level, fluent, beginner, and main task to capture what is more like a phrase that you write describing your current job position, for instance, what you did. And to pre-annotate, you have several setups possible. So here, unlike the former use case, we can't use a QA model because they only output 1 span and we have several skills per resume. Our first intent was to have the LLM extract the spans with the start and end position and basically do the whole job for us. But that didn't work very well, and instead of spending time on trying to improve that, we switched to a different approach, which was asking the LLM to extract just the pieces of text expressing the skills, and then coming up with a post-processing step to find ourselves the start and end position in the source text. But when I say the LLM, I actually mean a LLM, and you might want to try a couple different ones. An important factor to consider is how will you run it. One option is using an API, again, if it's not problematic to send data to a third-party provider, or you can run it locally. You have tools like LM Studio, which we used, or OAMA, for instance, which are nice to get local servers up and running for many models available, but you'll need to choose a model that can fit on your machine. Or you could deploy bigger models to remote servers. For instance, at LOwork, we like to use OVH AI apps, which are basically Docker images running on GPUs. And we combine that with VLLM, which is another library for LLM inference and serving. So these are just a few options, but choosing your infra and how you will run your model is the first step. Also, in our case, language was another constraint because we wanted to work mostly on French and English resumes. And it's not too difficult to get a model to extract text from English text, but candidates for French are a bit scarcer to find. Sometimes prompting in English, even if the task is in French, works better, but sometimes not, so you need to try. We also stumbled upon cases where the LLM would understand the input resume, highlight good skills, but return them in English, or worse, like a mix of French and English. And it makes it more difficult to then look for the original span in the text, because the simple regex won't work anymore. And bearing all this in mind, on the right you have the list of the main models that we tried. So we wanted to try different types, different teams behind them, different sizes also. And another crucial point is, can you get the LLM to do what you expect, and with enough stability that you can actually plug it into a pipeline? And to make up your mind, you'll need to play with it. Look at different documents, see how it goes. For instance, we worked on a prompt which gave pretty good results for most models, but with Llama 3.1, the outputs were very verbose, and as you can see, the phrasing kept changing from one document to another, which was really a pain to deal with. And getting a proper and stable output is core because the goal is to automate things as much as we can. So for that, we checked for two metrics. First, the proportion of resumes which gave a JSON valid output, and also the proportion of outputs which were as we expected, so like for keys, string arrays, etc. Tweaking your prompt to ask for a certain format can help, but only to a certain extent, we think. Then one option is to simply write a custom code to post-process the output, so we did several iterations of that. At first, we simply strip the markdown that you have around the response, or we use a library called JSON Repair to deal with like extra brackets, missing commas, stuff like that. We also tried to manage cases where we got either extra keys or different names for the keys that we were expecting, like competencies instead of skills, for instance. You can see the improvements in terms of the percentage of good documents that we got back. And also you can see that some models, they give better JSON results than others, more compliant to what we were expecting. But getting a structured output is something a lot of people want to do. So you have plenty of tools to help you do that were mentioned also in the previous presentations. Some will just tweak the prompt for you. Others will reprompt the LLM to ask it to either validate or correct itself until you get a good response. But that's more calls, so more time and money spent. And another approach is to apply constraint at generation to sort of control what the LLM outputs and only allow tokens that are compliant with a regex or a grammar. So we tried two of these libraries, outlines and guidance. Our experience is that outlines was easier to use and the integration with the LLM was really convenient for us. But they are both intended for structured generation, and guidance can actually do more, stuff like capturing named output or interleaving code and generation, so it could be helpful for your use case. They both did a good job at not returning unexpected keys, and we noticed also that we got less hallucinations than the unconstrained models. But some drawbacks are that they are meant to work on self-hosted models. So if you're using the OpenAI API, for instance, it won't work. Some APIs might offer the same capabilities, though. You need to look into that. Outlines also return the prompt in the output. So it's not a big deal. We can strip it, but it's yet another step to add to the post-processing. And we got more problems with guidance because we stumbled upon many cases where the LLM would get stuck stuttering, so it was like endless generation, and we had to introduce a timeout, and we lost documents because of that. So at the bottom, you can see the results, taking the raw output plus the prompt stripping thing for outlines. And for us, outlines gave better results than guidance, and results that were on par with the unconstrained models, plus the whole post-processing that we had come up with. Okay, so now how do you choose? Some metrics we can compute. In orange, you have the number of entities that were returned by the LLMs. We can see that the small models, 5.3, new extract, they return less entities in total, but they were as good or even better sometimes for short and standardized entities. So that's languages and certifications. But for the skills or main tasks, which are usually longer expressions, the bigger models were better. And another important KPI is the proportion of hallucinations. So we get a lot less hallucinations for languages and certification. Again, it's better defined information. And what's interesting is that new extract really lives up to its promises because it returns almost only entities found in the source text. So it's a model based on 5.3, but by the numbers, you can really tell the difference of intent in training. It's meant for extraction. But we also think that numbers can capture everything, and choosing a model will also be a matter of finding the pre-annotation that will help you annotate in the fastest and best way possible. And to get a better grasping of this, you might need to just look at some outputs and make up your mind. And this part is just harder to automate. To wrap up, for this use case, we like this LLM approach because well, first, it's multilingual. I mean, we are not English native speakers, as you can tell, but the team can deal with CVs in English as long as they are pre-annotated, and we also think that it could apply to other languages as well. And also, it proved to be quite efficient for some types of skills, especially technical skills or anything mentioned in the skills section of the resumes, and of course, the spoken languages. But we also found some limits. For instance, LLMs, they tend to correct typos in resume, and in this use case, it doesn't help because we rely on regexes to find the spans in the original text. We also need to deal with homonyms when the LLM outputs French in the example as a language, which occurrence is actually the appropriate named entity in the text. And also, we asked the models to deduplicate skills, but what if a person mentions the same skill twice but phrased differently? We should analyze how much we missed because of that. And also, most importantly, we find it still hard for a human to judge what is worthy of annotation for this particular task. It's really difficult because you have many ways of expressing skills and stuff in resumes. And the LLM sort of helps, but it doesn't do the job 100% of the time for us. So in the end, what can you take home from this talk? We think that LLMs are not the perfect replacement tool. Like, you can't rely on them to do all the work, at least not in every project. But it sure speeds up the R&D phase. And how much we gain depends on the task. Sometimes it will be good for data selection, sometimes data pre-annotation, or sometimes data auto-annotation. It depends. And in the end, we also found that you still have to put some effort into creating your data set. But the work, at least from a data scientist point of view, I think, the work is less boring and also more scalable, like Sarah said, once you come up with a good setting. Okay, so that's all. Thank you for your attention. Here you have a contact. And if you want to know more about Hello Work and what we do, you can scan the code.
Question?
Thank you for the great presentation. I have a small question and then a real question. The small question was like when you showed that with the outlines you get 91% valid JSON, so 9% are not valid.
Yes.
Is it because of the stuttering or?
Not for outlines, because we didn't get this stuttering problem, but we just got some results that when we the check for that is very simple. We just tried to convert the string as a dict, and it didn't work for some reason.
Okay, I'd be curious to know why. But anyway, so the real question was like, when you review the annotations from the LLMs, what tool do you use? I mean, do you use any tool? I'm curious to know.
We like to use Label Studio.
Label Studio?
Label
Okay.
Studio, yes.
Right. It's a good interface for NER and...
Yes.
Okay,
It's
thank you.
kind of like Prodigy, but
Yeah.
open source and free.
Thank you, very interesting. Quick question or two questions. First is, why haven't you used a bigger model, and why do you think API is not safe? And the second question is, why didn't you use tool calling, function calling to get the right JSON?
Okay. So for the first question, indeed, we could have tried bigger models. We didn't because we got satisfying results with Mistral 7B, which is the one we ended up using for our use case. And it was enough, so we didn't see the point in exploring more models, although it would have been really interesting, but we don't have like as much time as we want to do all the experiments we want, sadly. And also the second question was about why did we use tools to...
Function calling. So you define the structure that you expect. It's used for agentic model. So you get the right JSON, the right model based on the predefined structure.
Okay, well...
And then you don't have the JSON issue anymore.
We could have explored that. Yes, we went the outlines route, and again, in the end, that's the one we ended up using. We wanted to compare to different tools, but again, there were so many tools that we had to pick a few.
Makes sense. Thank you.
Hi, thanks for the talk. I'm interested in generating a data set for classification. So these were both extraction use cases. So in the classification case, there is this, you have to define what the labels are and explain that. Do you have any experience with such a use case?
Yes, I don't know if you did a little bit. I know that in the team, other people's did that for classification. I don't know if you have examples. No, but yeah, for instance, for not job offers, but like courses offers, we want to classify them into like a couple hundreds different categories, and we don't have annotated data, and we tried to annotate it with an LLM. We're still exploring that. It's better than nothing. It's not perfect.
Yeah, okay.
We also try to generate new data when we have few annotated data, and use them to ask to generate new data that look alike but are not exactly the same. We try to have this approach too.
Like
I mean,
the
we
word
have
classes.
kind of this problem with the generation that the variance is not high enough. So, right now labeling is the issue. Thank you.
Yes, thank you. In the end, the task was, of course, to create a training data set that in the end the model could train on. I was wondering, could you give some insights into how harmful badly labeled examples are for the training, for the final model performance? Like, would you rather have a data set with 1,000 examples and no false labels? Or is it better to have, 100 times as much examples, but then with a bit worse quality of, for example, 1% mislabeled?
I don't have numbers to give, but in the training data set for the salary extraction, when I open the file, the first example, it's wrongly annotated. So I know there are still errors in the trained data set, but I work on the variety in the data set, and it really helped because the language model tends to make the same errors. So if you work on the variety, you can reduce this effect.
Okay, thanks.
I have time for like 1 or 2 questions, if there's any. Okay. I see.
Hello. Thanks for the presentation. So, like, human annotation are usually bad, and like they're not perfect. So my question is more like, how far are these LLM to annotate text better than humans? What's your opinion on this? Are we far? Is ChatGPT 4, for instance, even better than humans when annotating and labeling datasets?
Well, I mean, we have annotated many data sets for the different projects that we do at Hello Work, and we always have wrongly annotated data in our data sets. Like when we, for instance, when we have a test data set and we will compute some metrics for a model that we're training, and we want to look at the errors to see what is the model doing wrong. Sometimes, not often, but sometimes we see that actually the prediction is better than the annotation, and that was true both for human labeled data and LLM labeled data. So I guess it's just something that we need to live with. Last week we were at another conference in Nantes where someone was giving a presentation and explaining how they once they have a test data set and they compute metric on that, they review all the examples where they have errors, and they correct the ground truth based on that, because sometimes the prediction is better, and they need to do that to get, I guess, a more accurate measure of the performance. But they tried to do that on the training data set also, thinking, well, if all my data is true, then it's better. And they noticed that they didn't get a great improvement, like just 1 point on the F-score or something like that, so it wasn't worth it for them. So, I guess it could. Sorry? Yeah.
Okay, I think we are out of time. So thanks again for the speakers.
Thank you.